So, good day, ladies and gentlemen. We'd like to introduce you our webinar today and a warm welcome from our side. My name is Martin Heinz. I'm board member of iTech. I'm together here today with two colleagues. They are both specialists in MES and in their specific field, and they'd like to introduce themselves as well.
Good afternoon. My name is Martin Strempel. I am a business development manager at iTech, and I'm responsible for the data analytics and business intelligence part of the business.
Hello from my side as well. My name is Patrick Wouters, and I'm the responsible product manager for low-code at iTech.
Okay, perfect. Thank you, Martin. Thank you, Patrick. So the 2 days webinar is one of a 6 of a series. So I'd like to show you shortly the series we like to introduce as well today. So today we are starting with future-proof digitalization of production processes with the MES. And within the next 2 weeks, that means in the 14th of December, we will start as well the second one, which is dealing with big data, IIoT, data analytics. Which we will touch as well today, but only in a short time frame, and we will extend this as well during the next webinar in December. Then in January, we have a, let me say, additional focus on e-mobility. Within that webinar, we like to show you how we are able to integrate processes in a e-mobility production area, as well to meet there the compliance and manufacturing requirements. So the fourth one is dealing with what we are calling flexible production. So that means as well how we are able to transport material flexible into the production environment to have a clear understanding in which time we have to deliver the material in the right, let me say, manner and in the right time and quantity, and to be as well as much as flexible as the customer from your side as well need that. So and the fourth one, which will take place in March, we like to have a deeper look in a scenario, what we are calling closed loop scenario. That means starting with a simulation approach, coming from the simulation, going forward into the production scheduling. That means advanced planning and scheduling, and then end up, so to say, into the manufacturing execution, and have as well to the way around, going backwards with the data of the production process back into the simulation to build up a kind of a, so to say, optimization cycle. So on the last webinar of the session or of the series will be in March with a dedicated focus on medical production. So therefore we like to introduce the functionality we are able to provide for a simplified production process to increase as well efficiency and to reduce as well the often 2 days used paperwork. So that's the series as it is defined today. And looking forward in the 2 days agenda, you will have a short overview concerning iTech. That means where we are and what we are doing. So and then an overview of the production itself. That means looking a little bit backwards into the history for the industrialization, and as well looking forward and to define how are the impact, for example, of Industry 4.0 are related to MES and MOM. And we will have the second one, which is dealing with, or the point number 2 for today is low code. So therefore it's part of Patrick. Patrick will show you how low-code functionality is integrated into our solution and what does it look like. And the third one is held up by Martin, which is dealing with IIoT and data analytics. And at the end, we like to end up with a Q&A session. Therefore, I'd like to invite you right now to post your questions into the chat. That means you can be active as well. You are invited to post all the questions you have, and based on your questions, we will be able to answer that as well in the Q&A session. So the chat is already opened. So, thank you, gentlemen.
Thank you.
I'd like to introduce you later on. Coming to a introduction of iTech. So on the iTech side, we have more than, or roughly 25 years in experience in manufacturing execution, provide different functionalities into the field. iTech belongs to the Dürr company. Dürr is a machinery company with more than 17,000 employees. So that means a huge brand behind us. And we on the iTech side are dealing especially with MES and manufacturing execution and manufacturing operation management in the field of a discrete manufacturing. If you look into the branches that we are focused on, for example, automotive, electronics, as well high sophisticated industries, which are dealing as well with a dedicated discrete production process instead of a other process. So combined with the product or the functionalities itself, we are able to provide as well the necessary and needed services. That means going forward with the customer to define the requirement, to define as well the specification for integration of the whole system into the customer environment, integrate for sure the system together with our team and the customer on site in the production environment, and to be able to deliver the necessary support with the whole life cycle. And for sure, training and so on is as well integrated into our service package. So that means we are dealing with the production area and we will be able to deliver different functionalities into the market. So on delivery is well done by a iTech group. That means not iTech as a alone standing company. We as well part of iTech group with our daughter companies. One is the company Dualis, located in Germany. The other one is the company Kochiscan, located in Canada. Both companies are part of our whole production portfolio, and based on all of our strengths, we are able to provide combined and joint functionality into the market based on different aspects. And if you look into the production requirements we see, so there are more or less three basic requirements we see still in the market. And honestly, they are not new, so they are there for a long time. For sure, there's a little bit change behind, but basically we're talking about a reduction of time to market due to the fact that we have still shorter innovation cycles of a product. That means as well, you as a company has to be able or the ability to integrate production process as well much more faster than in the past. And in addition, we have more complex production processes we have to manage into our production area. So that means as well, if we have on one hand side more complexity, then we have as well a complexity out of a flexibilization. So that means that's often the situation that a company is dealing with a product which is produced in a kind of a mass production on one hand side, but on the other hand side, there's sometimes a demand for a dedicated product produced in a one-piece flow. So there's a quite gap in between. On one hand side, you have a mass production. On the other hand side, you have a one-piece flow. So, and the demand as well, looking forward to a MES or MES solution, as well a solution like that has to be able to deal with both in one system. So that's a demand or requirement we see as well in the market. And based on that as well, for sure, increasing of efficiency is and was all the time a major factor of development and industrialization. And that is well a part I'd like to show in the next slide. If you look a little bit backwards into the history, then we see that the industrialization started at the end of the 18th century with the first mechanical loom. Then at the end of the 19th century and beginning of the 20s, the first production line are used in a slaughterhouse. And then later on into the production area of Ford, they used the first time a conveyor-based system for their mass production. And then we go forward into the 1970 to build up the first logic as a PLC-based system, so to say, which is able to steer, manage, control different lines or a dedicated production area. So that as well, these systems are as well in place. If you're talking about the PLC, then most of the time the PLCs are already into a production environment, but combined right now and connected with upper systems like MES or MES systems. So if you look into the nowadays, then we are talking about cyber physical systems. That means not only a dedicated system, there's more intelligent into the system. And at the end, if you look into the time schedule, or we look as well into the future, then there is a increase of complexity we have to manage. There's an increase of complexity within the production area. There's an increase of complexity within the different supplier networks. We have to go forward and we have to manage. And we have as well an increase of data, especially into the production area. So, and if you go forward a little bit as well in that way and to see how we captured the data in the past and at what time we started. So in the 1970s, we started with the MRP, which is Material Requirement Planning. There's a MRP1 and MRP2. Most of you quite knowing this kind of functionality. Then it starts with the ERP systems, beginning of the 1990s, with for accounting most of the time. But right now, if you're talking about the ERP system, that's not only accounting, there's a lot more behind as well, including material logistic and so on, but not really dedicated, integrated into a manufacturing area, because that's not the way ERP systems are able to act. If you look into manufacturing area, then we need a system which is able to react quite fast. There's a kind of a dedicated communication needed with the machines, and that's normally not part of the ERP, but that's part of the MES. So in beginning with the 2000 years, there were a discussion and a definition of the MES systems. And if you look to a European definition or in the US, there are different institutes, organizations who defined the functionality scope of a MES. So, but right now we are in a situation that we are ahead at that time. So that means there's a gap between 15, 16 or 17 years between the definition first of the time of the MES and the situation right now. So that means on the other hand side, right now we are talking about enlargement of the MES, enlargement of the MES functionality, and there's a need behind, because we are talking about IIoT, we are talking about big data, we like to have a predictive functionality in place, and we are talking about digital twin, for example, to have a clear understanding on the data we are using. So, and that's exactly where it comes from. So, because if we are talking about the influencing of the Industry 4.0 initiative, which were started in 2012, there's a clear understanding that the production processes itself, they have to be flexible. They have to be flexible as well into a integration. If you're talking about integration on a vertical integration as well in a horizontal integration, that means not the integration only into a company, a dedicated company, but as well over the border into different companies, as well into different production areas. And for sure, then we have to talk about integration of big data, cloud-based functionalities, and nowadays as well, we are talking about IIoT platforms. And that leads us as well to the key aspects in that field, which are, for example, interoperability. So that means how the MES or the MOM system is able to integrate itself into a customer environment. So therefore, different functionalities and for sure different interfaces are needed to connect the shop floor, to connect as well the upper level systems like ERP, like PLM, or PDM systems, and that's a major functionality MOM has to provide as well. So then we are talking about decentralization and virtualization. So that's a IT aspect which is more or less standard, but if we are talking about decentralization of logic, then we have to deal as well with, for example, edge functionality. So that means there's some logic and intelligence dedicated in a edge available. So that's a kind of pre-processing and then communicating all this information or a part of that information into a centralized functionality, which is able to go forward with this information. So that means decentralization is a important topic as well for us, and that leads us to a requirement of real-time communication. For sure, within the production area, there's real-time communication needed. Otherwise, you are not able into the production area to manage the production process and the quality in a right manner. So, and from a system perspective, we need a service-oriented and a modular system. So that's well the answer from our hand side, to have a MOM in place, which is not longer a monolithic system. We define the MOM as a service-based, a microservice-based system, so that we are able to have dedicated services in place with a dedicated data management, and the microservices are able to communicate with each other. That's one hand side, and on the other hand side, a microservice can be deployed on a IIoT platform and will be able to communicate as well with microservices from different vendors. So that's as well an important part, to have a system in place which is able to integrate into a overall digital strategy. Beside or in addition to the function, to the technology, there is as well a needed functionality. So as mentioned before, the architecture is a fundamental part of it. But we need as well a decent functionality portfolio to have a clear picture on how we are able and to gain benefits within the production area. So that means the production system itself has to be scalable. Then we need different connectivity. That means connectivity to the shop floor. And I think you know already the demand on shop floor side. There are different machines in place. We are not talking about only greenfield projects. There are a lot of brownfield as well. So that means the system has to be able to communicate and connect older systems as well, the newer ones. That means there's a wide range of interfaces, connectivities, which are able to communicate all the needed production data and information. So then going forward with the functionality portfolio, then for us there's a traceability functionality that's more or less a basic functionality, but we enlarge the functionality dramatically, so that we are talking about active traceability, and that combines not only the visualization of any kind of a stuff which is produced into a production area. That's combined as well with interlocking and verification on the material side, on the product side, verification of the BOM of material, whatever you like to have into a production, we are able to have as well a functionality for interlocking in that part. So based on the production process itself, there for sure is a quality data. So that means we're collecting all the different information out of the process and able to display that quite easy and shortly, so that the worker itself has a decent overview of his process and to be able to act if there's something wrong or if there's a deviation concerning the expected output. And that's the same situation if you're talking about production management and all the needed KPIs, which is OEE and all the other one. That's out of the box, coming from the portfolio. And that's not new and not special. That's as well part of the MES. But we enlarged as well the whole system with a dedicated material management system, which is able to control as well the material flow. There's a transport control behind, which is able to control as well the HEVs to have a clear understanding what would be the best way to integrate for example, the HEVs into a material supply concept, and combine this as well with the order management. So that means based on the order management, there's a clear understanding what would be the perfect situation in a production environment to have a prioritized order, and that's the outcome of the so-called APS part of the system. And that includes as well not only the information which would be the right order, there's as well an optimization behind to use the right machines, the right lines in the right time, to have as well the right worker in place for a decent work order. And to know as well about the equipment, because if the equipment is not able to produce in a decent time, so the APS has to reflect as well that situation and combine it in a really processable plan. So at the end, we are talking about different functionalities, and we have a lot of data into the MOM system. Out of the BI functionality, this means business intelligence, we are able to provide the data in the right format to different levels of management groups, for example, to know what's going on into production area and to have a transparent process. but we like to have a little bit more, and so on. That's the reason why we integrated data analytics. So, and with data analytics, we are analyzing not only the MES data, we combine the MES data with IoT data, and Martin will show that as well later on in this section, what are the benefits on that hand side. But at the end, we like to be able to predict different cases. So we like to have a prediction of maintenance, and we like to have a prediction of quality. So, and to close the circle there and to reflect as well one topic of the webinars we have as well, that's the simulation. So beginning with the simulation of a line, there's a clear understanding how the line should look like, how about the process data, how about the process time. And what we like to do is that we will collect the information within the execution area and then put it back as well into the simulation. So that means really to use the digital twin, first of all, for the incoming information into the MES, and then going backwards as well with the execution data back into the simulation to build up a kind of a optimization circle. So that means there are a lot of benefits behind. So I'd like to give you one benefit which is as well important for us, because the MES is as well a toolbox. So that means it's the MES or the MOM system is highly standardized with a high standardized portfolio, but there has to be as well a functionality for custom specific environment. So, and that's as well part of the system. So that means we are able to integrate as well custom specific functionalities. For example, built up with low code, which will shown by Patrick as well later on, to have a clear and a full MES or MOM with a standard portfolio enlarged with custom specific functionalities. So, and that's what we like to have and like to show you as well today within the next part. So I like to close let me say, the first section here with a question, and I like to invite you to participate here in the survey. So what we like to know is how you are able to produce the data into your production area or into your production. Is it with a MES or MOM system? Or is it based on a ERP system? Or based on different systems which are more or less or not connected together? Or is it paper-based? So, and we like to have the answer, and we would show the answer within the Q&A session. So that leads us to the next one, to Patrick. Patrick will show you the low-code functionality. Stage is yours, Patrick.
Thank you, Martin.
You're welcome.
So regarding low code, it's a highly discussed topic, and we should take a deeper look onto it. If it's worth of investing, if it's worth of taking the low code approach into solution design. So when the Forrester Group 2014 talked about the low code technology, they highly underestimated the disruptive character this technology brings to the market. I'm pretty sure that quite soon two teams emerged. On the one side, we had the ones that believed low code was some kind of miracle that could be handled as the solution to meet the rising demand of customized applications. While on the other hand, some traditionalists believed that low code is nothing less than low quality encoding. So we should take a deeper look and see which chances low code bears, which challenge it wants to solve, and if it's good or bad for the manufacturing environment. So, but before we go much deeper into the low code topic, I want to ask you once again, please address the following questions you might have based on low code or other topics inside the chat. Thank you very much. So, why choosing low code when there are no code platforms, and what is low code in general? Low code in general describes the simplified solution approach that allows so-called citizen developers to deliver applications, for example, for the shop floor. So we have a simplified development cycles with a powerful framework that delivers plenty of out-of-the-box functionalities. So one functionality might be the auto-completion feature in the dashboard, or another functionality, which I like most, is the drag and drop functionality. So when we talk about components in low-code, there are plenty of pre-configured components that users can choose to configure their applications. I will show you later on in the front-end and back-end part how this is done. But what is low-code all about? Is this all? No, it's not even close, because low-code tries to build a bridge between two often misunderstood departments in business. So on the one side we have the business department, and on the other side we have the IT department. Yes, and the IT department always is looking for additional developers and runs in resource problems, and on the other side the business is interested in having limited costs and reducing costs, and also the time involved into the development cycle. And low code seems to be an organic fit to meet or be the solution to this problem. So we saw a much faster deployment, a much faster and improved deployment cycle on low-code approach, and we also limited the involvement of developers, since we can use citizen developers, for example, as well, like I said. But let's see the critics as well. So what's about low-code means low quality. We identify it as the following. No-code is another solution approach that involves no coding at all. It's a similar platform than low-code, but like I said, no coding is required. No-code is the representation of, let's say, limited functionalities and simplified development approach. And therefore, we identified in no-code all these aspects when we talk about low quality. So based on the limitations and based on the missing data integration possibilities, for example, which are highly required in the time-critical shop floor applications, or also data-intensive applications, we identified that low-code is the way to go, and no-code is too limited for this approach. That's why we choose low-code as superior over no-code. But enough about definitions, let's jump deeper into the topic. One question from my side. Please answer the survey, which is trying to identify what do you think about the potential of low-code in your company. So do you already use low-code applications, or would you rather see it as a kind of economical justification? I will go back to the survey later on during my presentation, so please take your time and answer it. Thank you. So regarding our technology stack, we have a kind of splitted approach. We decided to have a front-end part and a back-end part. This is based on performance issues or performance reasons, because at the end of the day, we can address the whole MES or MOM functionality inside of our low-code applications. I will go down into detail on this, but it's just to keep in mind we have a back-end and a front-end part. So regarding the back-end part, it is very important to understand whenever there's information required, or I want to modify some data on my shop floor, on my manufacturing environment, when an IMS API call is involved. Those IMS API calls represent the functions that are some kind of carrier for the data. Yes, and whenever I want to have one or more information, like for example, I'm interested in seeing at the production station which is my currently assigned production order running on this station, and apart from that I want to see the following work orders as well, or for example which material is consumed during those work orders, then I would need some kind of workflow, some kind of sequence. And we at iTech call this workflow custom function. So whenever a business case is tailored to our solutions, we use custom functions to address them. This is very important to understand for the backend part. So let's see how we identified or how we built those custom functions in the past. Before low code, you can see in the picture above, we did a two-step approach. So basically, in the first step, we identified the IMS APIs, which were needed to follow this business case, and we structured it in a logical way, showed the constraints on it, and after all those aspects were identified, we jumped into the hard coding part. So please keep in mind, whenever we talked about the custom function, a standard custom function, we had somewhere around 500 to 2,000 lines of code. So as you can think, writing this code and also maintaining this code and deploy it is very time consuming, and at the end of the day also cost consuming. So what could be an approach to reduce the costs and also reduce unnecessary iterations on the design on custom functions? And this is where low code comes into the game. So regarding low code, as a possible solution for this, we have a drag and drop modeler that allows us to pull those IMS APIs which are required to trace those data or follow the business cases of the customers. We take those IMS APIs, drag them inside of a workflow modeler, connect them, and then we created a custom function. That's how easy the custom function design is based on low code. Apart from that, it also identified that it is a very powerful backend tool for applications as well. So it's not only a tool on iTech side that allows us to build custom functions, we also used it to model some backend logic, some decision-making structures for our transport control module, for example, and when it's about deciding which transport routes should be taken. So there we see one advantage as well, because we can easily modify parameters and set up our over 400 different IMS APIs and build the custom functions the customer needs for the business cases. So enough of the backend, let's jump into the front end part. When we talk about the front end, we use an editor which is browser based. So this approach supports obviously also the cloud deployment approach. And you can imagine it like the following. You have the drag and drop components you can easily pull into your library. So when you have a business case and you want to, for example, address some information, or you want to see the information in a table, you pull in a table. You want to have an input field where you can search for a specific work order number, you pull in an input field. You want to have a button for executing an API or a query in this case, you can pull in a button as well. And this is how you can build up an application. Apart from that, not only the drag and drop functionality is superior, you also have different and plenty functionalities that support developers to not do bugs. In this case, for example, we have auto-completion functions, or we have a simplified data integration, which I will show later on. But before I go into a use case or some kind of imagined customer use case in this case, I would like to address the survey one more time. So let's look at the survey and see how the results are. So I need to take a look. Okay, perfect. So we see like the most answers are for low code as a supplement to standard functions. So we see low code has been understood as an extension for some standard software in this approach, or the standard modules of our software, for example. But we also would like to address more sophisticated business cases as well. So it could be interesting for you to watch this use case I will present you right now. So let's jump into this use case. As you can see here, we have a very simple client that allows different functionalities. So these clients, they can easily be embedded inside of the existing MES or MOM solutions from iTech. And with that being said, it's the approach of building a simplified solution, for example, or a simplified client, is to address the operators at the shop floor, for example. So they don't need all the functionalities that we provide. They just need a very limited set of functionalities. In this case, the functionalities we are talking about is a line assignment, a production station assignment, and also the possibility to see which work orders are currently assigned to the production station and which is the currently running work order on the station. Apart from that, additional functionalities would be a label print or also the modification on the quantities. So I could, for example, mark rework or scrap units in this case. So with that being said, the building of this application and also the whole integration and testing and deployment and debugging and so on, it took around 2 days. So we needed 2 days for the back end, and a half day was on the front end of the 2 days. So it really showed how fast applications can be done without unnecessary iterations, without unnecessary overhead costs, and so on. But let's jump down more into this use case because it's very good to show you how the front end is connected with the back end. So we can see here, for example, the auto-completion feature I've mentioned plenty of times before. So in this case, I would type in an API or a function which is connected to the front end as well, and I would automatically get the answer from my server or from my API or my query, whatever I would like to integrate, and then I would have the possibility to display the right information. So in this case, I just type in the function which is needed, and then it shows me all the containing data fields, for example. Another important thing to understand, the data source integration is very simple in the front-end part. So after I modeled a front-end part and I've added the functionalities to the widgets or the components I would like to have, then I can take care about the data integration. And going more down the line, we see here, for example, the response of such an API call. So we have an API call here, which is based on a low-code workflow, and here we see the JSON response. It is very important to keep in mind, it's not only limited to a complex low-code workflow or a simple low-code workflow. We can also easily embed our MES API calls, we can embed external scripts, we can also run some queries on an SQL server, so there are plenty of functionalities to integrate inside of our low-code applications. And this is just one idea, for example. In this case, the button execution pulls the query and ensures that the data is displayed inside of my table. So let's see how the backend is connected to the front end. When we talk about the workflow modeler, I showed you already a more sophisticated workflow. This one is a pretty simple one, and as you can see here, this is one of the advantages of the workflow modeler as well. We have a very transparent requirements engineering, so everybody could easily understand, based on the notations in this workflow, what is meant or what has been done by the custom function, by the workflow. So this is really an advantage as well. Like I said before, at iTech, we have over 400 IMS APIs that follow every business case you can imagine. So it's not important if it's a simple workflow or it will be a difficult workflow, because we can address everything inside the low-code applications as well. So one thing which is important to me, I would like to address as well, is the low-code application design is not limited to simple clients. We can also, for example, take care about legacy software and integrate functional parts. So we could follow almost every business case you can imagine. It's just important that you come to us and ask us if we can do it based on low-code, for example. And we will provide you a solution. And after 2 or 4 weeks, for example, you would have a pilot where you could test the functionalities, and we could run down further the line to build your customized UI. So let's see what we're talking about, which advantages we identified doing the low-code stuff. So low-code is a framework that enables application development in a new way. It's much more simplified. It enables citizen developers to build applications, and it has a lot of advantages as well. When we regard requirements engineering approach, it's not like going with a candle in the dark. We know exactly the processes, we know exactly the front end, everything is documented, so we have some kind of living specification, one single point of truth, which is beneficial when it comes to software development and also understanding and maintaining code or all the applications. Another important feature as well is the rapid creation of those applications. Like I said before, time is money, and we not only reduce overhead costs, or we not only reduce resource involvement, we also have a much faster deployment of those applications, and we can test them also much faster. While on the other hand, we don't have big downtimes based on the versioning, based on all those embedded features, which would be too much to tell you right now. But a lot of features enable that we have a versioning as well, for example, and we have a reducement in the downtimes. So when we talk about a go live, it's just a one-click action, basically. So the deployment process is simplified very, very much And with that being said about simplification and a better understanding, IIoT is another emerging technology in the MOM environment. So for this, I would like to ask Martin to come on the stage. Yeah.
Yeah. Well, thank you, Patrick, for that very interesting presentation. If I had to take 2 points away from me, I would see that really with this technology, you have the option of implementing new functionalities so much quicker, but at the same time being able to reduce the risk while implementing it.
Yeah, exactly. And we also reduce the costs in a significant way.
Yeah, I think that's something I know many plant managers will be happy about. Huh?
Yes.
Yeah.
So
Thank you. Right. But I think that's also a good way to introduce the next topic. So taking that, I think what we understand with IIoT and the smart factory is very much exactly about that. We want to take these artificial intelligence algorithms and actually help production reduce their risk and even improve their efficiency considerably. And I think it's important at this page to basically let's define what we mean with AI. What do we mean with artificial intelligence? And artificial intelligence is a new way of programming, a new kind of computer software that we've been developing for a number of years now. It allows us to take the concept of how a human thinks, the ideas, and how we process information, and we started to program computers the same way. And we're seeing huge benefits by doing this. So suddenly we're basically solving problems that we never thought we could solve before. And it's at that point where we're actually solving these problems that we thought till now always would require human intelligence. And we're using it in our everyday lives already. We see, for example, just alone, if you look at your cell phone and you're taking a picture and you see how that cell phone moves around with you while you're taking pictures, that is face recognition, that is AI running in the background. The same way your Siri, your Google at home, or even your Hey Mercedes or Hey BMW in your car, that's voice recognition. There's all AI technology behind this, driving this technology and giving you these new features. But at this point, we have seen that many of our customers have recognized this advance and what the value is of using this technology. But importantly, and I think this is also what all of the consulting firms keep emphasizing, this will become very important in the future. And if you don't invest in it, you won't be able to, at least to the same degree, be able to recognize quality problems or production problems, either in real time or in the future, actually, ideally, in your production line. And with this technology, we're really striving for unimaginable production efficiencies that we just can't achieve without it at this point. So, but here's the bad news. So it's not that easy, and there are challenges. And if we look at the statistics that I'm showing here on the screen, there is a significant number of projects that fail. And I think it's at 13% here. This is quite a bad statistic. I mean, 1 in 10 projects actually only make it into production. So we have to, at this point, ask ourselves, what is the reason? Or maybe if we want to optimize the question, ask what do we need to do to make sure that we don't fall into this group and that we can actually then implement our future and an AI or an artificial intelligence project successfully in production. So I've been working at this or in this field for 10 plus years now, and I have seen this time and time again. And these points that we highlighted here, I think, are key, and they express sort of the key areas where I think if these are understood at the beginning of a project, one has a much better chance of a good success or a much better success rate and a chance of actually completing the project successfully. And by successfully, I mean actually having that project run in live production and actually returning value back to the company so that the benefit that was realized at the start can be shown and proven. The first point that I would like to bring is and mention is the connectivity aspect. And this is often forgotten. We see that if you don't have a machine connected, you can't get any data from the machine. And if you, as an organization, you need to consider this right from the start. One has to understand, how do I want to get this data, not only now today, but also in the future into my system. And we see 2 basic strategies of how people cope with this. The first is to basically upsource and upskill within the company so that people can actually connect machines and connect equipment themselves. The second one is actually to look for a partner or strategic partner who can help with the implementation and brings this know-how in. Obviously, MES service provider is ideal here because that's essentially been their core feature or core competency for the last 10 years. And so they bring a lot of know-how with them when they actually enter a new environment. On the additionally, maybe one point that I would like to add is just to also consider that technology has progressed, and now we're getting to a stage where a lot of these machines are getting to a modular point. We can use a flexible system where we can configure them and have the machines up and running quite quickly without requiring huge amounts of integration and development work. And this obviously brings huge benefits with it, reduces your hidden costs completely. I mean, you can imagine if you develop a project now for one line, you can take that, copy paste it to the next line, set it up for a different equipment maybe, but you're basically ready to go in a much shorter time. Whereas in the past, you might have had huge integration efforts each time you wanted to implement even the same use case. Lastly, or second point actually at this point, is what I'd like to call the streetlight effect. And I think this is something that's well known in research too, and it describes the bias that we have when we have data presented to us. So I'll tell you a short story just to get everybody onto the same page. So a man is looking for his keys in the dark and under a streetlight, and a policeman approaches him trying to help. Together they look for the keys for about 2 or 3 minutes. After which the policeman asks the man, are you sure you lost your keys here? And at that point, the man asks, no, I lost my keys in the park. So the policeman doesn't understand this and has to ask the man, well, then why are you looking for your keys here? And the man replies, well, there's light over here. It's so much easier to look over here. In the park, it's dark. And I really like the story because I think it gives that understanding of how we actually approach data analytics in production sometimes. We connect machines and then we try and find a use case that we can take and use with that data and try apply it to it. And if you think about it, it's really inefficient. So yeah, if I can give you my experience, the first is make sure that you have a proper use case before you start. You don't want to look for a use case that fits to the data you have. The second is that you really want to actually make sure that you do that then in steps, what I call a bottom-up approach, to take the process, understand the process, and then look, how am I going to connect that machine and that data to solve the problem? And then lastly, and also very important, is make sure that you design the end system or the system for the end user at the end of the day. He's the person or she's the person who's going to be using the system. And so often I've seen systems installed where it feels like an IT system, or you have to employ data scientists just to understand what the results mean. And in production, that doesn't help you, right? Eventually, that information of whatever the system is trying to tell you needs to go to the person who has to make the decision online about what to do with this information. The last point is actually an interesting one, and this is brought up by a real big giant in the field, Google. And so just to show you that this is not unique to production, they, in this puzzle that I've presented in the slide, are actually showing us that the AI component is only a fraction of the whole problem. So even Google is telling us that they spend a fraction of their time actually solving the AI problem. The rest of it is spent on the rest of the infrastructure and building that up so that that AI use case can be solved in real life. And that is a very important thing for us to take with when we're looking into production too. All too often, we set up departments, we employ data scientists, and we don't know where or when we're going to develop this rest of the infrastructure, and suddenly our business case falls apart because it's been pretty expensive up to now, but suddenly now we find out that that's only 1/10 of the total costs, and with that we make the decision normally not to implement it in production. So at this point we've seen that it probably makes sense to use a platform, some sort of platform, because that allows you at least to scale these additional costs across multiple companies. At this point, I'm going to just offer you a teaser because obviously we don't have that much time today. So that I invite everybody to please join us now in 2 weeks' time on the 14th of December. We'll go through all of these points in a lot more detail, and if can open up discussions about all of the things in much more detail too. At this point, I would just like to highlight some of the points that I think you should be aware of before you start these implementations, so that you can also understand what is important when you're actually looking at a IT or IIoT platform that can scale across production. Number one is to consider streaming analytics, right? We've seen low latency and high data rates require this. If you don't have some sort of streaming analytic component and you're only using cloud-based systems, you run into problems. The second is you have to consider how you want to integrate this with an MES. This is a prerequisite for IIoT. Without it, you can't create unstructured data from structured data. The a modular approach we've touched on. How do I make sure that I can connect new equipment as quickly as possible? How do I make sure that I'm decoupled from where I'm trying to apply my use case? Then we need to consider, in this one I'll say both data analytics and big data. We want the latest tools. We need to know what data there is. And we also need to consider feature engineering. It doesn't just help that we write all the data into the cloud and then hope that we can figure it out later on. And then lastly, we're also at a point in industry where we can now offer end-to-end complete use cases for our users. That is, take what we have, make it available to everybody. Everybody, in German there's a phrase, everybody cooks with water. That's exactly the thing. We all experience the same problems. So for these problems, why not buy the latest state-of-the-art technology in an end-to-end solution and implement it in your production environment? So at this point, we've reached the Q&A session. So I'd like to invite my colleagues back, and we could look at some of the interesting questions that you have posed us.
Perfect. First of all, thank you, Martin. Thank you, Patrick. I think we're really interesting parts we could see on low code and as well on artificial intelligence. And indeed, I think there's a huge field where we are in and where we are able to gain different benefits out of these different functionalities. Mm-hmm. So to summarize shortly a little bit, we started with an overview concerning MOM, MES, as well requirements on the production side. We looked a little bit in the past, and then from the past we looked forward into the future. We saw rising complexity. There would be an answer, or you expect an answer as well, based on out of a MOM system or MES system. That then we like to predict as well the future. That's as well part what Martin described as well. So that means we would be able to deliver a end-to-end solution. So that's our approach. And right now, let's have a look into the survey and into the answers and to see how many people are working already with MOM, MES, or with the ERP, or with different systems. So, and here is the result. So, there are already people or companies are using MES and MOM solutions. So they are sometimes as well ERP integrated into the shop floor. It would be interesting to hear where, let me say, the border is on that hand side. Some different systems as well, sometimes isolated, are in place. I think that's a typical situation if we are talking about brownfield and legacy systems. But the good point is here, only a few are using paper as a base for production data. And I think that's the right way. So we are looking for digitalization of all the different processes. And that's why we are here. And that's why we are established as well the webinar series. So and then coming to the next and look into your questions. So right now I'm trying to, let me say, to see a little bit about the different aspects. So let's have a look. So there's one question concerning the conjunction between IoT platform and MES. So does a IoT platform replace or complement MES or MOM? So Martin, what do you think about it?
Well, I would definitely say that it complements it. I do sometimes see literature saying that it will replace it, but I don't think so. I think the key features of the two systems are different. On the one hand, one has the MES, which is much more focused on the traceability and being able to substantiate how things got there. And then on the other side, we have the IoT, which can do a lot with the data, right? And I think those two complement each other very well. We will always use the IoT to give us more value from the data that we're collecting on the MES side.
Okay, Martin, thank you. There's another question. Interesting to answer that. So why should I go for iTech's MOM solution instead of competitor software? Patrick, what's your point of view on that?
Well, in my opinion, one of the main advantages to go for iTech is the functionality on the one side, and on the other hand, the modularity. So regarding other competitors, they often kind of clustered their competencies within very fixed interfaces. And at iTech, we have this IMS API approach. We have the custom functions. We have IIoT. We have low code. So you can easily, it's like being a child in a in a sweet shop. You can easily take this and that, and it will work. It will be fine at the end of the day. So we proved in many cases that we are able to provide sophisticated software based on a very specific business case where other competitors were not able to follow this. And for example, low code or IIoT, or also the whole enlargement of MOM in this case, is one of the facts why it's possible.
I think in addition, there's in another point. So we are targeting all the time, let me say, end-to-end solutions. So that means end-to-end solution based on a functionality portfolio. So that, as an example, if you're looking into AI or data analytics, so for sure there are a lot of different products or functionalities or solutions in the market. But what we are trying is to combine our solution together with so-called structured and unstructured data. So there is no need to have behind the or beside the MES or MOM a additional solution. So what we are trying is to combine the different functionalities into one solution, to have only one approach instead of having more than one. And then it has as well a complexity to combine as well the results or the data together. So that's as well my opinion on my insight. So going forward to low code. So there's a question regarding the complexity in software development. Why should I use low code instead of conventional development approach? Especially because low code can get complex too. Yeah,
Patrick? Of course. So this is a good question. At the end of the day, you can also you could choose pro code, but you shouldn't, because it is all about reusability. It's all about maintaining. It's all about understanding software. And when we do this low-code approach, it is very simplified to understand and also to maintain. So, of course, we can model, or we can deliver, or you can easily deliver software on your own if you're interested in the low-code technology as well. But regarding the entrance barrier of delivering it in pro code, so in the other ones, the conventional development approach, it's much more simplified and much more efficient. So whenever you're touching the software, once again, you will be happy that you used low code instead of the pro code solution. So.
Okay, thank you, Patrick.
You're welcome.
So, and there's as well a related question to low code. So what is the reasonable time difference for implementing a IoT use case in production? No, that's part of your production, your part.
IoT, sorry, in case of production and?
Yeah, it's only in case of production.
So yeah, what I'm going to understand out of the question is sort of, if we have a complete use case, how long does that take versus how long do we actually require normally? So in normal, I think a good rule of estimate is that if you're completely going to start a use case from scratch and you have the process know-how in your environment, you're going to look somewhere, depending on how well it runs, between 4 and 6 months at least, if you're doing well, to actually implement that use case. With end-to-end use case, if you're looking at that, you're suddenly down to 3 to 4 weeks, where you can actually take it from unpacking it, plugging it into your production line, and actually having that value reflected on your production process or in your production line. So considerable, I would say.
Okay, thank you very much. So, and then there's another question concerning IoT. Does iTech also implement custom use cases for IoT?
Well, we are always interested in use cases. We're expanding our use case the whole time. Currently, we've also set up actual a smart factory that we use to actually build up these use cases. And so yes, we do definitely look at setting up custom use cases, but also we want to make as many use cases available in our library and make that as available to as many of our customers as we can, so that they can pick and choose which use case actually reflects a pain point they have and implement those quite quickly.
Okay, thank you very much. So there's only time for one short question or answer, yeah? Otherwise we are running a little bit out of time. So there's a question, would you go with PLM and MES? MES, MOM will make ERP obsolete in the near future. I think there has to be ERP in place for sure. MES MOM will not replace the ERP, and we will not replace PLM, for example. But what we will say is that there's a decent area where MOM is dedicated much more better than a ERP system. That's all about it. We need the ERP for sure. There's everything concerning the master data as well, other functionalities which are needed for the companies. But that's the reason why we never would like to replace ERP or PLM for sure. So that comes to the end. So we are nearly at the end. So at least we like to show you again the whole series we have. We would like to be glad to see you as well again within the next webinar, maybe as well in a webinar with Martin.
On the 14th of December, I'll be back, and I'll be happy to discuss all of these things in a little bit more detail. Today was rushed, so we would like to show you so much more, and a very interesting field, and therefore I hope that we will have a good viewership there.
Yeah, or you can choose another webinar, which is as well mentioned on the slide here. So would be glad to see you back. For me personally, it was a quite interesting time together with you guys as well, together with the audience as well. Thank you very much for your activity, asking questions, and as well using the survey. So thank you very much from my side as well. Yeah, I'd like to wish you a good day and a good time.
Yeah, thank you everybody for joining us. Yeah.
Thank you a lot. See ya.
See you. Bye bye.